Good afternoon, dear colleagues. My name is Artem Maximenko. I am a junior programmer at C3D Labs, Vision Department. Here is the agenda of my presentation. So today I'm going to tell you about two of our visualization components, Vision and Web Vision. I'll give you a brief overview on each component, show new and improved features for both of them, and finally tell about roadmaps. Well, we're moving to the first part, C3D Vision. First of all, I should remind you for the first time what it is. So this is a cross-platform graphics library which makes it possible to render any geometry, both 2D and 3D. Vision also has a name of visualization engine and provides the user developer with graphics possibilities. The slide shows the standard features, but Vision has even more ones. Okay, let's move next. And the first step of presentation is changes made to polygonal geometry representation. Let me remind you that this representation is designed to render an array of curves within the same geometry and provides high performance when drawing a large number of curves. Representation has a set of methods that provide managing curves separately and together as well. The next three slides show this set. So next, there is a new ability to render a 3D texture. To work with this functionality, it provides a special class. You can initialize some data of this class using a bitmap, texture, or other image format. The main idea of this functionality is to manage rendering a texture on your own. It becomes possible thanks to using of shaders. They themselves allow the user to independently control the rendering texture parameters in real time. And the short video shows how the texture functionality works. Moving to the next part. In new Vision version, we improved interactive manipulator. Now it has become interactive. Now it not only indicates scene rotation, but also has mouse reaction zones, which allows you to interactively control the camera. The manipulator has a number of settings to control the size of the axis and origin. For now, we have implemented two variants of how the manipulator looks, and it is shown on the slide. Continuing the topic of tools, I should dwell in more detail on new functionality called Explode. You may need this tool in cases when the model has a number of assemblies that have sub-assemblies or a lot of bodies inside, and therefore these bodies are not visible. You can of course hide bodies, but this is a very laborious procedure. It is much easier to blow up a complex model in one click using our functionality. Thus, the Explode should be perceived as a mode of displaying the model. Now let's take a look at two versions of how to use the Explode operation. A cut one with basic parameters and an extended one with even more parameters. So you can see the first version, a cut one, where there are only three main parameters: Explode control, sensitivity control, velocity, and setting of subassembly levels. It means if it is necessary to expand the level of subassemblies, in this version the explosion goes relative only to the model center. Now let's have a look at an extended version. Now more parameters are available, as well as three main ones. First of all, you can set the relative point of explosion. It can be the model center, as it was on the previous slide, the center of selected body or assembly, or even set of selected bodies or assemblies. Next, you can select which objects will be exploded, top-level assemblies or objects nested in these assemblies and deeper. It is also possible to set the mode of along what objects will be expanded. The next modes are available: explosion along the axis of symmetry, radially from the axis of symmetry, and both modes. Another useful functionality is worth mentioning, which provides the ability to hide the maximum and minimum sizes of bodies. And finally, let's see our Vision roadmap until the end of the year. One of the most important objectives is to improve performance of rendering. It is also causes a number of additional tasks. Another key objective is the searching geometric objects, including not only primitives, but also geometric bodies in general. Unlike the old tool, we are going to implement the ability to determine objects under the mouse cursor across the entire depth of the model by crossing the vector. Also, we will improve certain functions, such as search priority and object filtering. The new tool will provide setting the size of a search trap and is going to simplify selection of objects using mouse. We also will improve separate interactive tools related to camera control. In addition, we have planned to implement a new process walk. It will allow you to control the camera in an arbitrary way on your own. Another important task is documentation on vision. We are currently paying considerable attention to improving its quality. Well, let me tell about news on another main visualization module, C3D Web Vision. But firstly, it is also worth telling about the purpose of this component. So, Web Vision is a client-server module designed for rendering geometry in the browser. It provides camera control processes such as panning, rotating, zooming. What's more, the latter is available not only with the mouse, but with gestures on the touch screen. The visualization module also has functions to control visibility, run processes of dynamic section, and selecting geometry, both by simply picking under the cursor and by a frame and any other functionality. Let's consider the Web Vision integration scheme. It consists of two main modules, front-end and back-end parts. The first one is the NPM package provided for developers to embed in the browser. It has a TypeScript API to manage render properties. There are such as setting visibility of objects, coloring them, and interacting with graphics. The second module is designed for managing data, so it represents a service which manages converting, preparing data for visualization, training attributes, and so on. There is a real REST API to work with service in a way it is in microservice architecture. Now let's move to our tasks we are working on now. One of them is measurements. At the moment, we have implemented graphical objects for measurement, such as linear, angular, and radial dimensions. The TypeScript API already had the ability to create these objects. Now we have processes to create such dimensions specifying the points, but they are more for debugging. Also, due to a lot of questions about the functionality of the Web Vision, we keep developing our Web Viewer demo application. It is included in the distribution of our visualization components and is open source itself. It is necessary to demonstrate how you can interact and work with Web Vision. So on the left part of the slide, we can see managing custom camera views. I mean, in addition to standard views, you can create your own ones and switch them. On the right part of the slide, we can see the documentation for the front end module of Web Vision. It is obviously describes how to handle with vision methods and so on. At the moment, the documentation is available even in our web viewer on the site. We also added the ability to load several models into the workspace of the demo application. You can download one file individually, or you can separately make an assembly from several files. On the left part, you can see loading models and paths, and on the right one, managing visibility. Here we load the entire model and are just hiding the objects. Last year, we announced implementing the manipulators, operating just like ones in the desktop vision. At the moment, we have implemented a coordinate system, marker, so it provides the ability to see where which axis is directed and to navigate in space more conveniently. Also, we're currently working on the dynamic section control process using a manipulator. It is when we interactively move the section plane right in the scene. This manipulator is still in development, and it will be different than you can see now, as we will add the processes to rotate the plane. The most important improved thing I should tell about is how the C3D service operates. After version 1.5.1, the service now had the ability to run as a service on Windows and Linux. So you can register, install, remove, launch it via the start and stop functions using some processes that manage services. And to work with the service in the old mode, there is an interactive run command. You know, we call the run command and then also set up all the other parameters for launching, configuring, logging, etc. The second major thing facing us this year is performance improvement. Unfortunately, I can't show the model on which we are testing performance for some various reasons. Even the blurred picture on the slide is just taken from the internet to fill in the space. Such an unrealistic model. But I will try to describe the model on which we're now optimizing vision. It's more than 1 million geometric objects more than 100 million triangles, the model takes 3 GB of disk space. And it's despite the fact that we have a decent memory usage limit in the browser. There is no more than 4 GB. Also, it is desirable to draw at least 30 frames per second. Also, we should support dynamic loading to load only part of the model up to a certain limit, because as I said, we have a browser limit. And now let's consider how we want to achieve a better performance. First of all, we want to improve our dynamic loading. To improve visualization, we need to increase FPS and move to WebGL 2.0 to take advantages of its new graphics features. Also, we want to use a dynamic frame. It's when the rendering of the model is adjusted to the number of pairs. For example, you want to see 30 frames, and we will draw as many objects as we can to keep 30 frames. Also, we need to implement a level of details in order to reduce the data size transmitted over the network and the data size stored in the browser. Because, as I said, we have memory limits. And also, we want to use the browser's local cache to go beyond 4 GB limitation. And finally, let's talk for a little about small changes in the integration scheme of the Vision. I've showed a scheme of the previous version today, but how it looks exactly now. Firstly, I want to emphasize the problem with model files. We often hear from our users that they cannot open the model or it's very poorly rendered. Although, in fact, the whole problem is about format extension. I mean, we often get models after conversion that are not very correct for visualization. They have instances lost, the number of triangles increased, and generally bad triangulation. But now our C3D module have a lot of methods to fix triangulation. Search for instances, optimize mesh, stitch geometry. In the scheme, you can see the optimization module on the server side. So we want to add it directly to the service. There is also a new cache appeared on the scheme. There was a server one, and now there will also be a local one, which can be used not to reload data. Finally, we came to our Web Vision roadmap. And what can I say here? First of all, we have the main task to restore the visualization of PMI objects that comes after the conversion. Next, let's talk about measurement processes. Before, I already announced that we have measurements by points in the current demo app version. But now we need to implement geometry measurement processes. I mean, if we have a pipe, we can measure its radius, or for example, two surfaces at an angle to each other, and we can also measure an angle between them. Makeup functionality or red pencil. Now we're analyzing the ways and forms of development. We also want to implement embodiments and to zoom in with the frame. Also, we want to add the ability to the scene navigation processes. These are the processes fly and walk around the scene. So that's all from my side. Thank you for your attention.